viewers, welcome to Fusion Mobile Mathematics Clinic. Today we'll be treating a topic called polynomials. What are polynomials? Polynomials are expressions with ascending or descending power of variables which do not include negative powers. Give for instance, if we have x plus 3, or we have x squared plus 3x plus 1. Or for another example, we have 3 plus 2x plus x squared plus 4x cubed. All these are examples of polynomials. Now let's look at addition and subtraction of polynomials. Now, for us to add two polynomials, what we do is we add the variables or the elements which have the same power, which we may call like terms. Give for instance, if we are adding x cubed minus 4x squared plus 5x minus 1, and we are subtracting it, that is from x squared plus 4x plus 5. We are subtracting these two polynomials. Now for us to subtract them, we open the bracket, we have x cubed minus 4x squared plus 5x minus 1 minus, this minus will affect everything in the bracket, we have x squared minus 4x minus 5. Then we collect the like terms. That is the ones with the same power. X cubed has no other, there's no other one with the power of 3. So we'll go to the next power, which is the power of 2. So we have minus 4x squared. Then this one minus x squared. Then we go to the next one, which is plus 5x minus 4x. Then the last one, which is a constant, minus 1 minus 5. So let's simplify. We have x cubed minus 4x squared minus x squared. Remember that this one has a coefficient of 1, so the coefficient we add, so we have minus 4 minus 1, which will be minus 5x squared. Then the next one, minus 5x plus 4x, will give us plus x, which is the same thing as 1x, but we don't write the 1. Then the other one we have minus 1 minus 5, which will give us minus 6. So this is how we add and subtract in polynomials. Now let's go over to multiplication of polynomials. Multiplication of polynomials. Now, for us to multiply, I'm going to look at this. We said that for multiplication, you will take an element of one of the polynomial and multiply the whole element in the other one, add it to the other one. Let's use an example. It will be clearer there. So we have bracket a plus b multiplying x plus y. So what we do is we take one of the elements here, multiply all this, plus this element, this b, and multiply. Let's see what we mean. This will be a bracket plus b bracket x plus y. So this will give us ax, a times y will be ay, then b times x will be bx, b times y will be by. So we have that. If we have something like a plus b, and the other expression, we have 3 elements. The same thing we did here is what we do. We use A to multiply all these elements, add it to B, multiplying the other elements. So this will give us A times this straight away will be AX, A times Y, AY, A times Z, AZ, plus B times X will be BX, plus B times Y will be BY, plus B times Z will be BZ. Then the next thing is you simplify, collecting the items and adding or subtracting as the case may be. Now let's move over to division of polynomials. For division of polynomials, let's look at an example. If we have, e.g. we have x cubed plus 3x minus 3x squared, minus 4x plus 2 divided, let me put it under, divided by x minus 1. If we want to divide this, what we do, we use long division. X minus 1, and on this side, x cubed plus 3x squared minus 4x plus 2. Now, for us to do this, what we do here is we use the x to divide. So x, we divide x cubed as what? X squared. To cancel one of the x. Then we use this to multiply all the two elements here, x and 1. So x times x squared times x will give you x cubed. X squared times minus 1 will give us minus x squared. So for us to, we minus, so x cubed minus x cubed will give us 0. But this one, 3x squared minus, let me write it out. 3x squared minus times minus is what? Plus x squared. So to add themselves to give us what? 4x squared. Then we bring down the next variable, which will be minus 4x. Then we use the same x again. X divided by 4x squared. Cancelling one of the x will give us plus 4x. Then we multiply. This multiplied by this will give us 4x squared. 4x multiplied by minus 1 will give us minus 4x. So when we minus this will give us 0. Minus x. Minus times minus will give us plus. So that will be minus 4x plus 4x will give us 0 also. So we bring down the next one, which is plus 2. X cannot go into, so here we have this as our answer, x squared plus 4x as our answer, and plus 2 here as what we call the remainder. Note that when there is no remainder, or the remainder is 0, that means that the divisor, the expression we use to divide the given polynomial, is a factor of that polynomial. Now let's go over to factor and remainder theorem. For factor and remainder theorem, if we have f of x as a polynomial given, and we are dividing by x minus a, therefore if we have f of a, the expression or the answer given when we have f of a is called the remainder. But if f of a gives us 0, then x minus a is a factor. Let's use an example to explain this. Example. If we have For example, we have x cubed plus 3x squared minus 4x plus 2 being divided by x minus 1. And if, for instance, you are asked to look for the remainder, for us to do this, this x minus 1 is the one we are using to divide. So what we do is we equate it to 0. So that will be x minus 1 equal to 0. So we take minus 1 to the other side, making x the subject of the formula. So this will give us what? 1. Then we substitute for x equal to 1 in the expression. That is this expression. So we have, instead of x cubed, wherever you see x, you put 1. So that will be 1 raised to power 3 plus 3 bracket 1 raised to power 2 minus 4 bracket 1 plus 2. Then we solve. 1 raised to power 3 is 1. 1 raised to power 2 is 1 times 3 is 3. Minus 1 times 4 is 4 plus 2. So we now have 1 plus 3 as what? 4. 4 minus 4, 0. 0 plus 2 is equal to 2. So 2 is our remainder. But if we have another example, give for instance, we have another example, we have x squared minus 5x plus 4 divided by x minus 1. We do the same thing, that is, we equate the divisor, the one we are going to divide, equal to 0. So that will be x minus 1 equal to 0. So we make x the subject of the formula, x equals to 1. Then we substitute for x equal to 1 in the expression x squared minus 5x plus 4. So wherever we see 1, we put, or wherever we see x, we put 1. So that will be 1 raised to power 2 minus 5 bracket 1 plus 4. So 1 squared is 1. 5 times 1 is minus 5 plus 4. So here we have 1 minus 5 is minus 4. Minus 4 plus 4 will give us 0. So therefore, x minus 1 is a factor of x squared minus 5x plus 4. So this is how we use the factor and the remainder theorem. Having looked at factor and remainder theorem, let's look at some special polynomials and what they mean. First one we'll be looking at is a squared minus b squared. When you see this, this means a plus b bracket a minus b. This is popularly called difference of two squares. If you see another one like this, a cubed minus b cubed, this means a minus b bracket a square plus ab plus b square. Or if you see a cubed plus b cubed equal to, this equal to a plus b bracket a squared minus ab plus b squared. Now this expressions will assist us in solving some particular questions even in our JAMB examination. Now let's look at roots and graphs of polynomials. For us to find the root of a polynomial, what we do is we equate it equal to 0, that is, make y equal to 0. Then we find the value of x. We'll be looking at different degrees of polynomials. We're looking at the first degree, degree 1. We're looking at degree 2. We'll be looking at degree 3. First, let's look at degree 1. Polynomials of degree 1. Degree 1. For degree 1, it is popularly called linear equation. And the graph is also called linear graph. That is, it is a straight line graph. It is generally represented by y equals to ax plus b, where a is the gradient, is the coefficient of x, and it is the gradient. Then b is called the y-intercept. That is the part of the graph or the line that intercepts the y-axis. We have two cases where the coefficient of x, which is also the gradient of the line, is positive or negative. So if we have a as positive, the graph will look like this. This is the x-axis, this is the y-axis. The graph will go this way. But if it is negative, that is, a is equals to a negative value. Give, for instance, minus y equals to minus 2x plus 3. So that means the graph will look like this. For a negative coefficient of x, or a negative gradient, the graph will go this way. Now let's look at polynomials of degree 2. For this one, it is popularly called the quadratic equation or graph. It is generally represented by y equals to ax squared plus bx plus c. So c is the y-intercept. To find the root of this equation, what we do is you make y equal to 0. So by the time you make y equal to 0, we will now find the value of x using our factorization method or complete the square, as the case may be. But we have two cases for the graph. For the graph, we have two cases. We say if a, that is the coefficient of x squared, is what? Positive. If it is positive, the graph will look like this. It will go like this. Here x, here y. But if a is negative, the graph will go this way, having a kind of N shape for negative. Let me go over it again. If a, the coefficient of x squared, let me give an example. Maybe we have y equal to 2x squared plus 3x plus 1. Such a graph will have this kind of shape. But if it is negative, if for instance we have y equals to 3 plus 2x plus, minus x squared. You can see it has a negative 1 coefficient. It will have this kind of shape. So let's look at some examples looking for the root of a degree 2 equation. Example, let let's look at the first example. If we have x squared minus 2x minus 8 equals to 0, we want to factorize using factorization method. Now we look at how we can do this fast. To do that, we multiply these two. We have minus 8x squared, and this middle number minus 2x. So all you do, just add a bracket like this. Put x, put x. Note that the coefficient of x squared here is positive. So this is what we are doing here. Now, we will look for two numbers that when you multiply, you have 8. That is minus 8. And when you add, you have 2. Those two numbers will be 2 and 4. But you have to watch the sign so that you have it right. So we have the two numbers as, we said 2 and 4, we have it as minus 4 and plus 2. So when you multiply it, you have minus 8. When we add it, you have minus 2. So let's put it in here. Straight away, just put it in there. Minus 4. Remember, it is equal to 0. So we have factorized it. Then to look for the root, you now say x plus 2 equal to 0, or x minus 4 equal to 0. So x will now be taking 2 to this side, it becomes minus 2. Or when 4 minus 4 goes here, it becomes positive 4. So this is the root of this equation. Let's do another example. If we have 6x minus 5 minus x squared equal to 0. We said to equate it, we equate it to 0, so to find root. Now, first of all, we need to rearrange this equation so that we can find it. You will notice also that this equation has a negative 1 for the x squared. So it's a negative polynomial. So we have it as minus x squared plus 6x minus 5 equal to 0. Now we arrange it. The next thing you do is you isolate the minus sign. Minus, then you put in bracket x squared. This one you change to minus, so that when you multiply the negative sign, you have plus initially. Then this will be what? Plus 5 equal to 0. So this expression, when you open it, will give us the preceding expression. So now we can factorize. We factorize normally. We have the two numbers we are looking for as 5x squared, as a plus 5x squared, and the middle one minus 6x. So we'll be looking for two numbers that when we multiply, we have 5, and when we add, you have minus 6. The minus, don't forget the minus sign. You have the minus sign out here. So we have bracket, the two brackets. We put in the x. Then you now have, what are the two numbers? The two numbers definitely will be 1 and 5. How are the signs going to be like? We will have the signs as minus, minus. So when we multiply minus 5 times minus 1 will give us plus 5. Then when you add it, that is minus 1 minus 5 will give us minus 6. So let's go, let's put it in there. So that will be minus 1 minus 5. Then we now introduce this minus sign either to this one or to this one. If we introduce it to this one, it will be the minus sign will affect this, so it will give us 1 minus x. This one will become positive, this one will become negative. Bracket x minus 5. Or we can have it, the minus sign affecting this one as x minus 1 brackets, this minus sign will affect this one as minus x, and this one as plus 5, and you have that. So that is how we factorize when we are looking for the root of an equation. Now let's look at polynomials of degree 3. Polynomials of degree 3. These ones are called cubic polynomials or cubic equations. They are generally represented as y equals to ax cubed plus bx squared plus cx plus d. D is the y-intercepts. A is what we use to know if it is a negative polynomial or a positive polynomial. For the graphs, for the cubic polynomial, are two conditions. If A, the coefficient of x cubed, is positive, so the graph will look like this, x, y axis. The graph will look like this. Now, from the graph also, you can get the root of the equation. Like for this graph, this point where the graph cuts the x-axis, here, this point, and this point are the roots of the equation also. So, like for the degree 2 equation, which we mentioned earlier, so if we have, like for the positive and for the negative, these parts also are the roots of the degree 2 equation. If we have the positive one, where you have it like this place where it cuts the x-axis is the what? They are the roots of the equation also. Now let's move over to the second condition. If A is negative, so for A to be negative, this is the graph, so the graph will look like this. A being negative, also roots of the equation, root of the equation. You can get it when you read it there, where it cuts the x-axis. So this is how we find the roots and represent the polynomials in graphs. Now let's look at some questions from our JAMB past question. Look at the first one. If 9x squared plus 6xy plus 4y squared is a factor of 27x cubed minus 8y cubed, find the other factor. So the first question, it gave us 9x squared plus 6xy plus 4y squared, and it said it is a factor of 27x cubed minus 8y cubed. But first of all, let's look closely at the expression 27x cubed. Knowing that this expression is a factor of this, that this can divide this without remainder, and we are looking for the third factor. So, but when you look at the expression itself, this is the same thing as saying 27 is the same thing as saying 3 cubed x cubed minus 2 cubed y cubed. Which, if you combine it together, we have 3x cubed minus 2y cubed. Now, we established earlier that if you have a cubed minus b cubed, this is the same thing as saying a minus b, b squared plus ab plus b squared. So let's apply it in here. Since this is equal to 3 cubed minus 2y all cubed, if we expand it, we have the one inside, so we have 3x minus 2y, then this one, for this one square, bracket 3x squared plus 3x, bracket the second one, since it's AB, 2y, then plus b, that's this one, plus 2y squared. Close the bracket. So this will give us 3x minus 2y. This one will give us, that is 3 squared will give us 9 squared. Then plus, when you open the bracket, 3 times 2 is 6, x times y is xy. Then plus 2 squared is 4, y squared is y squared. So you will see that this expression is the same with this. So the other factor definitely will be 3x. So therefore, other factor is 3x minus 2y as our answer. First question. Now let's look at the second question. Solve for x and y if x minus y is equals to 2 and x squared minus y squared equals to 8. Now this is a practical example of a simultaneous equation, one being a linear equation as this one, and the other being a quadratic equation. But let's look at it. Number 2. The first equation, x minus y equals to 2. Let's call it equation 1. And the second equation, we have x squared minus y squared equals to 8. We established also earlier that when you see something like this, this is also called difference of two squares, which is the same thing as saying x minus y, x plus y equals to 8. So already we can see from our equation 1 that x minus y is equals to 2. So wherever we see x minus y, like this place, will now become 2 bracket x plus y equal to 8. Now let's go back to the other side. So this will give us x plus y equals to 8 divided by 2. 8 goes in, 2 goes in 8 will give us 4. So this will be x plus y equals to 4. Equation 3, let's call it that. So let's combine equation 1 and equation 2. That is, equation 1 being x minus y equals to 2. And equation 3, x plus y equals to 4. 1, 3. Now, to solve simultaneously, let's add. So when we add the two of them, using elimination method, this will give us 2x, but this one will be minus y plus y, which will give you 0. And this one will add to give us 6. So x will now be equal to 6 all over 2, which is what? 3. So we have x equals to 3. Now let's substitute for x in equation 1. So whenever we see x, we put 3. So that will be 3 minus y equals to 2. So y will now be equals to 3 minus 2, which is equals to 1. So we have x, y, x being 3 and y being 1. So that is how we solve question 2. Let's move over to question 3. Now, for question 3, we have find the remainder when x cubed minus 2x squared plus 3x minus 3 is divided by x squared plus 1. Now, if we had the divisor, or the one we are using to divide, as just x plus 1, that is not the x not having a power, we would have used our remainder theorem. But because we have that, we have to actually divide. So for question 3, let's divide. So we have x squared plus 1. Then what we are dividing, x cubed minus 2x squared plus 3x minus 3. So we said when we want to divide, we use the algebra to divide. That is x squared. X squared we divide x cubed, it will go there x. X times x cubed, x squared rather, will give us x cubed. Then x times 1 will give us x. But this minus 2 is not a like term to this, so we can't, we will not be able to minus or add. So we move the x to this side, x. So we have, when we minus, this will minus this as 0. Then 3, because this is a positive, 3 minus plus x. Let me write it out. 3x plus 3x minus plus. Minus times plus is what? Minus. So minus x. This will give us what? 2x. Then we bring down this one. So this will be this minus 2x squared. So we'll bring it down. Minus 2x squared is plus. So we use this x squared to go in minus 2x squared. X squared goes in minus 2x squared, we go there minus 2. So 2 will multiply this will give us minus 2x squared. Minus 2 times plus 1 will give us minus 3. But this minus 2 and these 2x and minus 3 are not like terms. So we move it to this side, bring down this one, this will be minus 3, then we have minus 3 down here. So we use the like terms. So we minus we minus this out. Then this one minus 3 minus minus and minus is plus. So minus 3 plus 3 will give us 0. So we bring down to x. Now we divide further. X squared to divide 2x is impossible. It cannot divide. So therefore, the remainder is equals to 2x as our answer. Let's go back to question 4. Question says, if 2x squared minus kx minus 12 is divisible by x minus 4. Find the value of k. Now, for us to say something is divisible, that means it will divide it without remainder. That is, x minus 4 is a factor. So if x minus 4, number 4, is a factor of 2x squared minus kx minus 12. So therefore, we can use our factor or remainder theorem. That is, we equate x minus 4 equal to 0. X minus 4 equal to 0. So we make x the solid formula, minus 4 comes to this side, this will be 4. So we substitute for x equals to 4 in 2x squared minus kx minus 12. So wherever we see x, we put in 4. So this will be 2 bracket 4 all squared minus k bracket 4 then minus 12. 4 raised to power 2 will give us what? 16. 16 times 2 will give us 32. Minus, we open the bracket, this will be 4k minus 12. Remember that we already know that this is a factor, so we already know that this will give us 0. So let's equate it to 0. So we add the numbers, 32 minus 12 will give us 20. So we have 20 minus 4k equal to 0. We take 4k to this side, this will be 20 equals to 4k. K will now be equals to 4 coming to divide 20, that will be 20 divided by 4, which is equal to 5. So therefore k is equals to 5. So that's how we answer questions pertaining to polynomials.